In this part of the tutorial, we will add joint relationship between different components in the assembly. We will use AsBuilt Joint. This is an incredibly useful tool for establishing relationship between components when they are in right location in the assembly in relation to each other. So here you can see, as my design approach was bottom-up building, so the components are already in right location. Now let's use the AsBuilt joint. Now first let's do some practicing. So this is an assembly. If I use the AsBuilt joint, so for the AsBuilt joint, just choose the type, and for our look, because of the type of the assembly, we will choose the slider option. So for the slider, it's really important that you choose the component in order. So the first component will be mobile, and the second component you choose will be stationary. And then you give a snap point which need to be in the sliding orientation. What I mean by is that if I choose snap point this orientation, you see it will move this way. But if I choose the snap point this orientation, it will move upwards, but it is difficult for the component to move. So it is basically not giving me the option to move. That's why the snap point need to be in same orientation you want the slide movement. Choose second time. It's not letting me choose. Now let's start again. So AsBuilt joint, first component mobile, second component stationary, and the snap point then you give the joint motion limit. So for the maximum, here you can see the arrow is pointing. If I just click it, so it's already moved 60 millimeter this orientation, and the minimum I just put it -60. So -60. Rest, I'm not choosing the rest. So if I do that, click on OK, let's see what kind of joint relationship we have just built. So click it. Here you can see it is sliding inside the bigger bracket. We will do the same for our design. So the first assembly, so the first joint, AsBuilt joint, the first component will be the mobile X-ray base. So choose the base, then choose the vertical beam, and the relationship would be rigid because I don't want them to be moving in relation to each other. So rigid, then OK, it's rigid now. Now the second joint will apply between these two. If I just zoom a bit, so remember the golden rule of choosing sliding joint. The first component will be mobile and the second component will be stationary. Then the snapping point need to be on the orientation of the slide movement. Then we will give it a limit. So minimum is where it is now, and maximum will be you just drag it, holding it and drag it. -400. Let's see the right orientation. So we can give it some more. $500, maybe 550. No, 520. So the relationship has already been established. Let's try. If I just click it, here you can see it is sliding up and down. Let's build the second joint relationship. AsBuilt joint again. So this one will be the stationary for this one in relation to the slider inside. Let's choose the first component inside. It's really difficult, so what I will do is I will zoom in. First component, the mobile one. Second component, the stationary one. Snapping point, this orientation. Here you can see it is already moving. Let's build the joint motion limit. So minimum is where it is now and maximum is should be 500. Okay, so let's see if it's really the relationship has already been built or not. Yes. Now the second joint, same rule again. The first component will be mobile and second one will be stationary. So the first one and the second one, then the snapping point is the orientation of the movement. Here you can see the first one is moving. Now minimum is where it is now and maximum is too much, 500, 300, 300, and no resting. So preview. Okay, let's check it. Yes. Home location. Now the collimator need to be in joint as well. Collimator will be rigid, but if I choose rigid, the whole assembly will be rigid. That's why I need to build the minimum joint relationship. What I mean by is that I will show you. So it is slider. So if the first one is mobile and second one is stationary, then snapping point any, because I'll give this way. Okay, now I'll give it minimum 0, maximum 0, so it will not move at all. If I do that, here you can see our joint relationship has been established and it is locating the collimator in relation to the bed in different angle and different orientation. To see it more specifically, with different multiple views. So here you can see the movement from different angle. Let's make it a little bit more visible with a bigger screen. Here you can see the component is doing up and down, back and forth, sliding motion.